Hello friends, today we will learn how to solve this question. This question was asked in CSIR net December 2013. Sorry, I wrote it 2014. It was asked in 2013. Okay, so the question is looking quite big, but it is very easy to solve. So I'm not reading the question, I'm directly explaining you the question. Okay, so the question is that there was the metal disc. This is the okay, so in the question they have given you this diagram and they told that this is the metal. This is the metal disc, and this metal disc is rotating, okay, about this axis. This is the axis. Okay, this is the axis, and this disc is rotating, okay, like this in this direction. Okay, and there is a magnetic field B. Okay, so there is a magnetic field B, and the direction of magnetic field is in upward direction. Okay, and there is a contact here, that is S. Okay, and there is another contact at the center of the disc. Okay, and there is a resist, there are, these are the wires. Okay, this is the resistance. Okay, this is the resistor. So they asked how the current will flow. So they asked the direction of the current, whether it will flow from a to B or B to A. So what will be the direction of the current? They want to know. They are asking from you. So let's see how to solve this question. So this question is quite easy, and this is based on the Lorentz force. Okay, this question is based on Lorentz force and is very easy to solve. So before solving, I want to tell you the answer. The answer is that the DC current will flow from B to A. Okay, so the DC current will flow from B to A. So here the direction of the current will be from B to A. Okay, so this will be the current. So let's see how we get this answer. So we all know the Lorentz force law, and the force on the so if we already know, let me explain you. If a charged particle Q, okay, if there is a charged particle Q and it is moving in the magnetic field B, okay, then a force acts on the charged particle. Okay, if it is moving with velocity v, okay, then a force acts on the charged particle Q, and the force is given by F equals to Q v cross B. Okay, so this is the value of the force which will act on the charged particle Q if it is moving with velocity v in the magnetic field B. Okay, so I have used this formula. Okay, so I have used this formula, okay, to write this formula. So here, since it is metal, there will be lots of electrons. Okay, so that's why I wrote the electron in place of charge. I wrote the electron. Okay, and this electron, and the disk is rotating. Okay, and this disk is rotating with the velocity. Some, you may assume that it is rotating with some velocity. Okay, so here consider that here there may be some electrons. Okay, okay, and the disk, since the disk is rotating, there will be some velocity. Okay, okay, of the electrons. Okay, okay, so so uh, 1 minute. Okay, so the force on the electrons will have this value. Okay, 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 so let's see the direction of the Lorentz force. Okay, so here, since this is the cross product, okay, or the vector product, the direction of this much only, let's first consider only this much only. So the direction will be of this much only will be given by right hand screw rule, and that will be perpendicular to the both v, if this is the v and this is the b. if this is the V and this is the B, okay, then the and this these and if this and so the direction of this quantity will be perpendicular to both the V and B, okay. So since by the right hand screw rule, first we have to first is quantity is the V and the next quantity is the B, so it will rotate from here. So the right hand screw will rotate in this direction, okay, and so the right hand screw will advance in this direction, okay, and this will be the value of V, means this will be the direction of V cross B, okay. Okay, and this vector will be perpendicular to the both B and V, okay. Okay, so this will be the direction of that, this is the direct, so this is the direction of this is here, okay. Okay, so now let's consider here, okay, let's look at the diagram more closely. So here you can see that this disk is rotating, okay, the disk was rotating, okay. So if there is some electron at this point, okay, then the velocity of the electron will be V, let's assume that it will be V, okay, and then the B is perpendicular to the disk, so the direction of B is here, okay. Now you have to note down that the the you have to note down here that this is that here the angle, here the angle will be the 90-degree, okay. So here the angle will be 90-degree, and by the right hand screw rule, the right hand screw will rotate from V to B, okay, from V to B, and it will advance in this direction, okay. So this will be the direction of V into B, okay. So this will be the direction of V cross B, and now you know the direction. So this is the direction, but you can see that this has a negative sign here, okay. So the direction will reverse, okay. So now the direction will reverse, and the direction will reverse, and the direction will be in this direction, okay, in this direction towards the axis. The direction will be towards the axis. Now this is the axis, okay. So the direction, so the force that will act on the electron will be towards the axis here, okay. So since because of this Lorentz force on the electrons, okay, so this Lorentz force acts on the electron, and all the electrons will get accumulated at this center. At this point all the electrons will get accumulated, okay. So here at this point there will be lots of electrons, okay, and at the outer points there will be scarcity scheme, that means there will be less number of electrons at the outer part, okay. So if you look at this point, okay, here there will be lots of electron, okay. So here there will be lots of electron, okay. So when the resistor is connected, the electrons will flow from, so there will be lots of electron at this point, and so this electron will flow from here, from this point, like this, and it will pass from the resistor, okay, from here, and that will go, and that will go like this, okay. But we already know that the direction of the current is opposite to the direction of the flow of electrons, so the direction of current will be from B to A, okay. So this will be your direction from B to A, and that's why the answer was the DC from B to A. So the current will flow from B to A, okay. Okay, thanks for watching this video.